Welcome to the second lesson in Session 2 on solving logarithmic equations. To solve a logarithmic equation, we rewrite the equation in exponential form and then solve for the variable. Here we have two examples where we're going to solve the equation for the given variable x. In the first example, we have 3 times the log of x plus 4 is equal to 6. The first thing we have to do is isolate the logarithmic equation. So to do that, we're going to divide both sides by 3, which leaves us with the log of x plus 4 is equal to 2. At this point, we've isolated the log and we're ready to convert into exponential form. So here we have a common log. Since there's no base expressed, we understand that that's a base 10. So translating that into exponential form gives us 10 to the second power is equal to x plus 4. To solve for x, now we just subtract 4 from both sides. Since 10 to the second power is 100, when we subtract 4 from both sides, we get x equal to 96. In the next example, we have log base 3 of x plus log base 3 of the quantity of x minus 8 is equal to 2. So we're going to use the product property of logs to condense and simplify the left side of this expression. So when we condense it into a single log using the product property, we get log base 3 of x times the quantity of x minus 8 is equal to 2. Now we're ready to translate into exponential form, which gives us 3 to the second power is equal to x times the quantity of x minus 8. Now we simplify and solve. Distributing the x gives us x squared minus 8, and 3 to the second power is 9. We see here we have a quadratic equation, and what's always recommended in a quadratic equation, if you remember from Tier 1, is to set the equation equal to 0, and in this case, factoring is going to be the most convenient method to solve. So factoring both sides gives us the quantity of x minus 9 times the quantity of x plus 1 equal to 0. Using the zero product property, we get solutions of -1 and 9. Now keep in mind that the log of a negative number is not a real number and is not an acceptable solution. So we have to reject the value of -1 in this case, and my answer to the equation is x equals 9. To solve an exponential equation without a common base, we can take the log of both sides and apply the power property of logarithms. So here we're going to solve each equation for the given variable, and we're going to round our answer to the nearest tenth. So we have 4 to the x is equal to 19. So notice the left and the right side cannot be expressed using a common base. So our method here is to take the log of both sides. Taking the log of the left side gives us log of 4x, and taking the log of the right side gives us log of 19. Notice on the left side we have log of 4 to the x power. So at this point we can apply the power property of logarithms and bring that variable out in front, and it becomes x times the log of 4 is equal to log of 19. From here we can divide both sides by the log of 4, and x is equal to log of 19 over log of 4. Now pay attention, this is important. This is considered a calculator-ready format. Once you're in calculator-ready format, you can insert that value into your calculator and get a true approximate rounded answer, which in this case gives us about 2.12. In the next example, we're going to follow the same process. Notice the left and the right side, 3 and 225, cannot be expressed using a common base. So therefore, we take the log of both sides of the equation, gives me the log of 3 to the x power, equal to log of 225. Now we're going to employ the power property of logarithms, which brings my variable out in front, and I express it as x times the log of 3 is equal to the log of 225. And now I isolate my variable by dividing both sides by the log of 3. Excuse me, log of 225 over the log of 3. And again, this is considered calculator-ready format. Inserting this into the calculator gives me an approximate value of 4.93. Now, using the method we just practiced to solve exponential equations provides us with a convenient formula to evaluate logarithms. It's called the change of base formula. The change of base formula allows us to express any logarithms in terms of the common log. For example, log of any base, we'll identify it as log base b of a, is equal to log of a over the log of b. So I've taken a log of any base and translated it and converted it into the common log. This works for basic basic scientific calculators often only have a common log. So here we're going to use the change of base formula to evaluate these expressions, and as always we're going to round our answer to the nearest tenth. So using the change of base formula, log base 2 of 7. So now we always put the base on the bottom when using the change of base formula. So if we were trying to evaluate log base 2 of 7 using the change of base formula, that would be the log of 7 over the log of 2, which gives me an approximate value of 2.81. Evaluating the log base 5 of 10, remember we put the base on the bottom, so that's the log of 10 over the log of 5. And evaluating that gives us an approximate value of 1.43. So that wraps up this lesson. Good luck on the quiz, and email us if you have any questions.